Question number 2. Figure 3 shows the route an aeroplane takes as it travels from an airport terminal to the runway, and a scale of 1 centimeter represents 70 meters. Question 2.1. Determine the magnitude of the aeroplane's displacement from the start to the finish point on figure 3. So you want to measure from start to the finish. And when I did measure it, I get 7.2 centimeters. You're given between 7.1 and 7.3. And the question 2.1 says to determine the magnitude of the aeroplane's displacement from the start point to the finish point, and we know the scale is 1 centimeter represents 70 meters. So we can then say for 7.2 centimeters, where 1 centimeter is 70 meters, therefore 7.2 centimeters times 70 would be 504 meters. Then the displacement is around 504 meters. Figure 4 shows the direction of the horizontal forces acting on the aeroplane as it moves in a straight line towards the runway. Air resistance here, this is the friction force in that direction, thrust in this direction. And question 2.2 says to determine the magnitude of the resultant force on the plane. So if there was any magnitude here, it might be in that direction. So let's assume that's the magnitude here of the resultant force. Then we can say that the total force going to the right must be equal to the total force going to the left. And that's the resultant force there plus the thrust here. And that should be equal to the air resistance and the frictional force. And so we could make the resultant force here the subject. So we go air resistance plus friction minus the thrust. The resultant force will be 4,500, the air resistance, plus the friction, 9,500, minus 14,000 for the thrust. And the difference between these two will be equal to 0 newtons. The resultant horizontal force will be 0 newtons. Question 2.3. Describe the motion of the aeroplane as it moves towards the runway. Well, the aeroplane then have a constant velocity. If there's no acceleration, the force will be 0. Or you can say it's in a steady velocity, it's got steady velocity, or you can say it has a uniform velocity. Any one of these is correct. Question 2.4. Air resistance and friction are contact forces. Give one other example of a contact force. Contact force might be upthrust or normal contact force or tension. Question 2.5. The aeroplane stops for a short time and then accelerates along the runway. Figure 5 shows a distance time graph, sketch graph, for the stage of the journey. Draw the velocity time sketch graph for the stage of the journey. Figure 6. Okay, from 0 to 10 seconds, we would draw a straight line there. We would draw a uniform acceleration or constant acceleration. Question 2.6. The aeroplane takes off from the runway, so its height above the ground increases. Figure 7 shows how atmospheric pressure varies with the height of the aeroplane above the ground. Estimate the atmospheric pressure when the height of the aeroplane above the ground is 10 kilometers. So we want to come to the graph and we want to draw a curve along the graph, a line of best fit. That's the curve along the graph. And then we want to mark the height at 10 kilometers. So that's 10 kilometers, that point there. And we want to draw a line going to there. And that gives us 28 kilopascal. So we want to come up here and write 28 kilopascal. So that would be 28 kilopascal. Question 2.7. What happens to the air surrounding the aeroplane as the height of the aeroplane above the ground increases? The average density of the air above the aeroplane decreases. The mass of air above the aeroplane increases? No. The temperature of the air increases? No. The volume of air below the aeroplane decreases? No. So it's going to be the first one, and it will be that one.